Hi, Akshit. How are you doing?
I'm good, sir. How are you?
Very good, very good. So, how was your semester?
It was pretty good, sir. Yeah, went pretty well.
How did you do in math?
I did really good, sir. I scored 98% in advanced functions and 97 in physics.
Perfect. Very good job. So, now you want to learn calculus so that you are ready for the calculus class, right?
Yeah,
That is great. And, that's kind of essential because once you have better concepts while getting into the subject, you can perform much, much better and
yeah,
appreciate the subject. That is very important. And from university point of view, calculus is one of the most important course which you do in mathematics for at school level, right?
yeah,
So we already had a session on pre-calculus and we understood what are the things required to get started with calculus, right?
right,
Today we'll begin with the very first unit of calculus which deals with limits. I'll
right.
give you overall view of limits, what limit is and how it is related with um, the concepts which you are going to soon learn in calculus and also the concepts which you have learned already. So, everything will come together. Advanced functions, you did touch about rate of change and instantaneous
Yeah,
rate of change. So you may have to recall that while we move forward with limits.
yeah,
Let me share with you one of the lessons which I have prepared on this topic. Now, this is one of my most favorite topic, and I hope you will like today's lesson.
yeah.
Can you see my screen?
Yes, sir. I can see it.
Great. So limits lesson one, we'll just talk about basic concepts. We'll begin with limit of sine x over x, which is actually equal to 1 when x is approaching 0. So this nomenclature, I'll make it absolutely clear for you. So we'll first learn the concepts of limits, then see how do we evaluate limits. You can evaluate limits from algebraic expressions or using a graph, which we'll check. And then we will see how do you find limit from the left side and from the right side. That is
Yeah,
mainly done for piecewise functions. So when you have two pieces joined at one point, limits could be different at that particular value of x. And we'll see how do we check that. And then we'll talk about continuity of a function and the conditions which give us continuity. Those conditions,
yeah,
of course, will be limited with the limit concept. And then we'll understand the type of discontinuities. We'll take up some piecewise functions and we'll also talk about this indeterminate form, which is kind of very important to understand as we move along.
right.
So sine x. So when you work with sine x, x, is a parameter which defines the angle. Now this is the angle of rotation normally. So what is the default unit for x? The angle.
Uh, Radians, sir.
Perfect. So
Yeah,
radian is the default unit for the angle, this argument x. You should not take degree as the unit
degrees. Yeah,
for the angle when you are doing calculus. Otherwise,
right.
this particular limit, which we are going to begin with, which says limit x approaches 0, sine x over x is equal to 1. This
One.
limit is not defined if x is in degrees. So remember that part. It is only
Yeah,
defined if x is in radians. So we will
radians.
check that part. So uh, limit basically is what? Let us say that you are approaching a point, and let me give you one example from rational functions which you have done recently. So let's see if you remember that. So let's say there is a rational function r of x, which is equal to, let's say, x squared minus 1 over x plus 1, correct?
Yeah,
This can be written as what?
x plus 1, x minus 1 over x plus 1. So there's a whole, sir, because x
There
plus
is
1
a
cancels.
whole, right? So this function, as you know, is not defined at x equals to minus 1, right?
Right.
So we can definitely cancel this away and we can write this as equal to x minus 1. However, the most important thing to note here is that for this particular function, x is not equal to minus 1,
Negative 1.
right?
Yeah,
Now, since we have a common factor in numerator and denominator, it means we have a whole at
x equals negative 1.
x equals to negative 1. Now, what is the value? What value do we approach at this whole? This whole is not in the domain of the function. So if
Right.
I actually sketch this particular function, then how will it look like? Well, let me just sketch it here. So it is x minus 1, a straight line with y-intercept of minus 1, right? Clear?
Yeah.
So it is diagonally moving kind of like this. However, at minus 1, it is not defined. So at minus 1, at this point, we should have a hole, correct?
Right.
Now, this hole is not in the domain of the function. However, we can approach the hole from both the sides. You get the idea?
Yeah.
So when I approach the hole from this particular side, what value, y value do we approach? So definitely, when I approach this hole for this particular function, which is equal to x minus 1, where x is not equal to minus 1, but we're trying to approach 1, correct? We are not at
Right.
1, right? So at 1, we're trying to approach and see what value do we get. So if I write minus 1 here, I get minus 1, which is minus 2. Correct?
Minus 2. Yeah.
So we are approaching a value of minus 2 when we approach minus 1. You get the idea?
Yes, sir.
So in technical terms, we have given it a very, this is an example, which is like very common. So every time we are seeing what value do we approach? Well, if we cannot be there, what is the nearest point where we can be, right? That is what
Yeah.
we are going to estimate. And we say, well, clear, whether you approach from the left side means from this side, and right side means this side, okay? And we'll write this as limit x approaching minus 1. If I write minus here, it means I'm trying to approach from the left side.
From the left side. Yeah.
For this particular function, which is r of x for us, and we'll also calculate the limit of this function while approaching minus 1 from the right-hand side.
From the right side.
And
Yeah.
both sides, when we approach, we see that we approach only one value, which is minus 2. Since we approach a value, which is a real number, we say the limit exists, because from both the sides, you approach at a particular value. So that
Okay.
becomes the limit of the function at that point. You get the idea?
Yes, sir.
You can't be there, but you know where you could be.
But
Think
you're
like that.
approaching it, right, sir?
Yes, you're approaching
Right.
it. Is that okay? So
Yeah.
this is the concept of limit, right? So with that, technically in calculus, we have given it the symbol limit LIM and x. That arrow indicates approaching a value a. In our example, it was minus 1. For a function f of x, our function was r of x, a value L. In our case, we approached a
Minus
value
2.
minus 2. And therefore, the limit of the function approaching that point was minus 2 in our case. And in general, if it is L, and L is defined, that means a real number, then the
Right.
limit exists. If it is not the same from both the sides, then we say that the limit does not exist. We'll take up those examples, okay?
Yes, sir.
So can you please read, how do we read this expression, which is written as limit x approaches a for the function f of x is equal to L. It is read as the limit of the function f of x as x approaches a is L. Is that clear? That is how you
Yes, sir.
read this function, okay? Now, a limit is the value that a function approaches as x approaches a specific value, which we write like this: x approaches a, right?
Yeah.
X approaches the a. This is the x independent variable. X gets closer and closer to the number a from either side. You have to approach from both the sides and get the same value. But x is not equal to a, right? There is a restriction. It's a hole.
Yeah.
You cannot be there. From definition, the limit of the function may exist even if the function is not defined at x equals to a, provided the value of the function approaches L from
From
both
both
the
the
sides.
sides.
That is very important to understand. Otherwise,
Yeah.
we'll say it does not exist, right? A limit is a value that a function approaches without necessarily being equal to as x approaches a specific value, correct?
Sir, so I had a question.
Yes,
So from the definition, the limit of a function may exist even if the function is not defined at x equals to a, provided the
Correct.
value of the function approaches L from both the sides, right?
correct.
So if it doesn't approach from both the sides, then it's not defined, right?
Yeah, it has to approach from both the sides, only then the limit exists. Otherwise,
Oh,
not.
okay.
We'll take up
Yeah,
that.
yeah.
Now, it is not necessary that the function may be discontinuous at this point. For example, for the same function, I could say, well, what is the limit of this function limit of the function when x approaches, let's say 1, right?
Right.
So when x approaches 1, we can substitute 1 here. We get 1 minus 1 is 0, right? So at that
0.
point, it is 0. So we find it is 0. So, and that also happens to be the value of the function at 1, correct? The value of the
Yeah.
function is also 0. You see that?
Yeah.
Now, that is another important concept, and that is to say, if limit exists and it is same as the value of the function at that point, then the function is continuous at that point. You get the idea?
Okay. Because in the other case, we had a hole, so it was discontinuous, but now
So
it's
the
continuous.
value did not exist, right? So it could
Yeah.
not be equal to that value, right?
Right.
But that didn't exist. In this case, it exists and it is same as the value of the function. Therefore, it is continuous at this function. So that gives us the rule for continuity. A function is continuous at any point x equals to a if and only if the limit exists and it is same as the value of the function at that point. You get the idea?
Yes, sir.
So that is the overall concept of what limit is and how we have conditions where it may exist and how from this concept we can also say that the function is continuous at this particular point. Is this all clear to you?
Yes, sir. Clear.
Perfect. So let's move forward and we'll take up example. This will be your homework question. So I'll not take up this. I'll come back to
Right.
this later. But let's talk about the sine x over x. So in
Yeah.
the beginning of the lesson, I said this limit when x approaches 0 is basically equal to 1, right? That's what I said. How do you verify it? Now you know that the concept is we are approaching this value 0 from both the sides. So when I write limit x approaches 0 minus on the top means I'm approaching from the left side.
Left side. Yeah.
Left side really means I'm 0 means you can be very, very close to 0. So let's say we begin with minus 1, which is very far away, come closer to minus 0.1, minus 0.01, minus 0.001 is very close to 0, correct?
Yeah.
Substituting those values of x and using your calculator, you can calculate these values. And you see, as you approach very, very close to 0, x approaches 0, you find that the value of the function approaches 0.999, means 1.
Really close to 1. Yeah.
Close to 1, right? Similarly, if you approach from the right-hand side, approaching from right-hand side means this is 0, and I'm coming closer to this. Let us say we start at 1, then we take about 0.1, 0.01, 0.001,
Yeah.
and we see that we get the value of sine x over x as 0.99999, which is very close to 1. So from both the sides, we are approaching one value, which is 1. And therefore, the limit of this function sine x over x is equal to 1. Is that clear to you?
Yes, sir. So this is similar to how we did the preceding and following interval in rates of change.
Perfect. Rate of change. So that rate of change is the derivative. It gives you the gradient at that particular point, right?
Yeah.
So we'll from the limit, we'll come to the definition of gradient, and that is calculus, finding gradient on any point on the curve, right?
Right.
So can you please read what have I written here as a statement?
Yes, sir. The limit of sine x over x when x approaches 0 from the left side is equal to the limit of sine x over x equals to 1 when x approaches from the positive side.
Both sides is 1, therefore the limit exists and it is 1. Now, can you put 0 and see what the value of the function could be? We have sine of 0, right? Sine of 0 over 0. Now, sine of 0 is 0, right? You know that.
Yeah.
And over 0. This is called indeterminate. 0 over 0 is not defined, correct?
It's not defined, right?
Not defined. So you see, the function is not defined at x equals to 0. However, we can find the limit that we can approach to a value which is 1. Do you see
Right.
that?
Yeah.
Correct. So that is what it is. Now, I'd like you to read once again what is written on the left side.
Yes, sir. The limit of f of x equals to L when x approaches a. Limit of a function exists at a if and only if the value of function approaches a real value when x approaches arbitrarily close to a from both the sides.
Correct. Now, can you try question number 1?
Yes, sir. Why limit 1 over x when x approaches 0 does not exist? Is it because you can't divide by 0, sir?
Okay, that is indeterminate. Okay, that you can divide by 0, that's indeterminate. But if
Yeah.
it is indeterminate form, even then you can find the limit, just as we found the limit. You get the idea, correct?
Right.
Now, if you follow this particular method of approaching from left side and the right side, where will you approach, right? Let us say, if you plug in, let's say, negative value here, right? So negative 0.1, if you put -1, you get -1 as your value, correct? Make a table like this, correct?
Yes, sir.
So from the left side, you will approach a value which will be very large, but a negative value, right?
Negative value, right?
And from the right side, you approach a very large positive value. Do you see that?
Yes, sir.
As you might remember, recall that this 1 over x is a function which is kind of like this, right?
Yeah.
So as you're approaching 0, you see you're not approaching at a defined point, at a real value, L.
Right.
It is infinitely large. So therefore, the limit does not exist. And it is also going in different directions. You see that, correct?
Oh, okay. So we can, because it's almost infinity, sir, we can't really
Yeah, it is not approaching any particular point. And that's
Right.
why it does not exist. Is it okay?
Yeah.
For this particular function, you might be in a position to find the limit at x equals to 0. If I substitute 0 here, what do you get?
You get 1, right, sir?
-1 over -1, which is 1. So in this case, the limit exists and it is 1. Do you see
1.
that?
Yeah.
So at times when the function is continuous at that particular point, right?
Yeah.
So if the function is continuous at that particular point, which is origin in this case, in that case, the limit will exist. The limit may not exist at some other point where it is discontinuous. We'll just check that. It actually exists here also, but we can check that. However, when you see a function with restrictions, you should try out, because sometimes the values given to you are on the continuous part of the curve,
Yeah.
where the limit will be same as the value of the function at that particular point. Is that clear to you?
Yes, sir.
Correct. So now we will see how do we evaluate limit with some examples. Can you please try the very first example A?
Yes, sir. Limit of x squared plus 2x minus 1 when x approaches 1.
Correct.
Right. So we plug in 1. 1
You
plus
just plug
2
in 1.
minus
So when you plug in 1, you get 1 plus 2 minus 1, and that is equals to 2.
2.
The limit is 2, correct? So the best
Right.
thing is, whenever you're working with a limit question, plug in the value straight. And if you get a value, that means value of the function is same as the limit, and therefore the limit is this. This is a continuous function at that particular point. So we have
Right.
learned the concept that if the function is continuous, in that case, limit is same as the value of the function. You get the idea? So
Yes,
just
sir.
plug it in, right? The idea is, if you can be there, why not be there, right? The
Yeah.
limit concept is for, if you cannot be there, how close can you be there?
How
right?
close
That's
can
the
you be?
limit.
Right.
But if you can be there, why not? Just be
Why
there,
not?
right? That's the whole
Yeah.
idea. Now, second one, limit pi plus 1 when x approaches 1 is what?
Right. So would you plug in 1 as pi, sir?
No, pi is
No, right?
pi. Pi
Yeah.
is not a variable. And so the answer will be pi plus 1 itself. This is a tricky question. I've seen so many times in the test paper, the students like get it wrong, just as you tried putting
Yeah.
1 for pi. Pi is a constant, right? It's
Right.
not a variable. And this function is just a constant. If you draw it, it will be a horizontal line. You get the
Yeah.
idea, right?
Pi
Pi
plus 1.
plus 1 will be a horizontal line.
Right.
And so limit at any point will be the value of the function, which is pi plus 1, correct?
Right.
Likewise, you can actually try many different questions here. You can see some of my videos and then try these questions out. Let's move
Yes,
forward.
sir.
Is it okay?
Yeah.
Now we will see how do we find limit of the function from the graph. Now in this part, I will also explain you what is the right-hand side limit, what is the left-hand side limit, right? So while
Right.
solving some questions, can you please read what is part A of this question?
Yes, sir. Limit of f of x when x approaches -4.
Okay, so when we say x approaches -4, you have to check from both the sides. So at
Right.
-4, what is happening? So -4 is right there, right? This is -4 for us. Now, when you approach from the left side, which value do you approach? You approach 2, right?
2. Yeah.
So when you approach from the left side, you approach 2. And when you approach from the right side, you approach again 2, right?
Also 2.
Therefore, this limit is 2. From both the sides, we approach one particular value, and we have a value, which is 2. Is that clear to you?
Yes, sir.
Now, part B, when you approach -2, so this is -2 for us. Let me highlight it. This is -2 for us, right? So at
Yeah.
this point, what is the limit of the function?
It's, well, it's not included, right, sir?
It's not included, it's a whole.
Yeah. So I think 2 and 2 from left
yeah,
hand.
so it is still 2. It is a whole, but still you can approach and you're approaching a value, which is 2. And therefore, the
Right.
limit is 2. Is that clear to you?
Yes, sir.
Now let's look into the next point, which is, let's say 2, right? So this function. So what is the limit of this function when x approaches 2? Can you tell me the answer?
Well, there's two possible answers, right, sir?
So when you approach 2 from the left side, then what value do you get? Left side, you're on this graph, right? And you're getting the value which is 2. Do you see that?
Oh, sir. I think I was looking at the point above it. As
Okay, above it from the right side. So what is the limit
Yeah.
when x approaches 2 from the right hand side for the given function, right? So in this case, you are approaching this value, which is 4. Do you see that?
4. Yeah.
Now these two values are not equal.
Right.
Since they are not equal, limit does not
Not
exist.
exist.
You understand now? So from
Yes,
the
sir.
graph, we see that the limit does not exist. We also note there is a discontinuity. This type of discontinuity is called jump discontinuity.
Yeah.
You get the idea, correct?
Yes, sir.
So that was an important point to check. So here, what is the value of the function at 2? What is f of 2 in this case?
F at 2 seems to be 4, right, sir?
Correct. And it is not equal, limit does not exist, but the value of the function exists at this point, which is 4. And since the limit and the value do not match, we say this is not continuous at this particular point. You get the idea. So we have understood the concept of continuity, limits, and all these things come together. And that's a piecewise function where now you understand clearly how do we find one side limit. Is it okay?
Yes, sir.
Now, some more questions based on this, which you can try, but let's look into this piecewise function now. So can you please read the question?
Yes, sir. Piecewise function. A function is continuous at a if the limit of the function is equal to the value of the function at a. Discuss continuity of f of x.
Correct. So this is an examination type of question where you might get this type of question, right? So it is a piecewise function. F of x is equal to x when x is less than -1. It is equals to minus x squared when x is between -1 and 2, 2 included, -1 included. And it is equal to 2 when x is greater than 2. So sometimes the graph is not given to you. You have to sketch the graph. For our lessons convenience, so that you understand, get a visual picture. I've already sketched the graph for you, right? So the left part is when x is less than -1, you get the straight line. You see that with slope of 1, correct?
Yeah.
And when in between, when you're talking about -1 to 2, both included with solid dots, we have a parabola which is going down, minus x squared, correct?
Yeah.
The third part of this piecewise function is a horizontal line whose value is 2 with a hole starting at 2 since it is greater than 2, right?
Right.
Now, if you look at this particular function, can you tell me why it is discontinuous at this point where x is equals to 2?
Because you get two values when you approach from the left and right, sir?
Left side limit is not equal to right side limit.
Right side
limit does not exist at this particular point. And since they are different, we have limits, right?
Yeah.
It leads to jump discontinuity. You get the idea?
Right.
Different. Many times we may have, limit which is like infinitely large. For example, for 1 over x, we got a value which was like approaching infinity, which is not a defined real number. Correct?
Right.
So in those cases, the limit will be infinite type of a limit. Is it okay?
But in that case, we would also say no limit, right? Sir? Does not exist.
You will say limit does not exist. Yes.
Right.
Also, we have seen another case where the limit exists, but it is not equal to the value of the function. Then the limit is of the type of a whole, correct?
Yes, sir.
So these are different things. And if the limit exists and same as the value of the function, it is continuous. It is a continuous function. So these are the things which are kind of important. Here is your test question. Can you please read question number 3?
Yes, sir, for sure. Find the value of the constant k for f of x to be continuous for all real numbers, given f of x equals x plus k when x is less than 2 and kx squared when x is greater than or equal to 2.
How will you solve this question?
Right, sir. So for it to be continuous, at at the point 2, both of those pieces have to have the same value.
So that means perfect. So 2 plus k is equals to k times 2 square, right? And you're going
yeah,
to solve this equation
solved
and
exactly.
then get your answer. Perfect.
Right.
So you have the equation 2 plus k equals to 4k. Bring them all together, right? And
Yeah.
you say 2 equals to 1 minus will give us 3. And therefore, k is equals to 2 by 3. And that gives you the condition for the function to be continuous, right? And once you
Yeah.
plug it in, you know the limit and the value of the function will match, which you can figure out after finding the value of k as 2 by 3. Perfect?
Yeah.
So that is how you are going to do it. Now, so in today's lesson, we have learned many concepts. Can you please revise what have you learned in today's lesson?
Yes, sir. We've touched upon the concept of a limit, and we've definitely saw how to evaluate limits and limits using equations, limits from graphs, and the concept of left and right side limits, the continuity of a function, types of discontinuities, piecewise function, and also indeterminate forms.
Correct. So that's the first part of the lesson. So I hope all these concepts are absolutely clear, right?
Yes, sir.
Now, what we will do now is we'll look into some examples and see how do we solve these questions. We skipped few examples, right? So
Yeah.
I'll leave some as a homework for you. However, we'll look into some to how do we evaluate limits. For example, this is another assignment for you. So you can
Yeah.
make a note of this assignment. Can you please read the question?
Yes, sir. In lesson 1, we evaluated the value of E, Euler's number, using the concept of limits. Given E equals limit of 1 plus x to the power of 1 over x when x approaches 0, use the definition of limits to find the value of E. Correct 4 decimal places.
Correct. So that becomes an exercise for you. So you should practically do this. That is to say, just as we found the limit for sine x over x, right?
Yeah.
As x approaches 0, you can find what is the limit of this function, 1 plus x to the power of 1 over x, when x approaches 0. Now here, if I write 0 here, what do I get? I get 1 plus 0 to the power of 1 over 0. That means 1 to the power of 1 over 0. This is another indeterminate form. Any power, like 1 to the power of infinitely large number, correct? So, 1 to the power of anything is actually 1. However, 1 to the power of infinity is not defined.
Right.
You get the idea. So again, we do have a function which is indeterminate form when x is approaching 0. But either way, it could be indeterminate, but we can find the limit as x approaches 0.
Right.
And the idea is we will see what happens to the value when we approach from the left-hand side and when from the right-hand side. When you do your calculations, I want you to do the calculations, okay? From the left-hand side, you approach a value, which is 2.71841. And also from the right-hand side, you get the same value. Do you see that?
Oh, okay. Yeah. And
this
that's a
is
constant,
the value
right,
of
sir?
E. This is the value of E. And therefore, many times in our calculations, especially in calculus, if you get a function which is 1 plus x to the power of 1 over x, it is E. You get the idea?
Yes, sir.
So try to remember this, a very important question from test point of view, and good to remember, okay?
Yes, sir.
Now, we'll get back to the point where we had to find limits of few functions. We did find, since we have some time on our hand, let's find limit of the function which is given to us in D. Limit when x approaches 0 for x minus 1 over x squared plus 1. What is the answer? Tell me.
-1, right, sir?
Yes, you just plug in 1 and you get -1. The next one. 1 over x minus x plus 1 when x approaches -1.
It doesn't exist, right, sir?
So if I substitute -1 here, I get 1 over 0. Now 1 over 0 is not defined, correct?
Yeah.
Now remember one thing, 1 over 0 is not the indeterminate form. 1 over 0 is not defined.
Right.
There's a difference. So there, the limit does not exist.
Yeah.
So if you sketch it, it's a rational function which will have a vertical asymptote at x equals to -1, right?
-1, yeah.
It's going to infinity. It does not exist, okay?
Yeah.
Perfect. Now, f. What is the limit as x approaches -1 for absolute value of x plus 1 over x plus 1?
0, right, sir?
Okay, let's substitute. So if I substitute -1 here, so I get -1 plus 1 absolute value divided by -1 plus
Oh,
1. So that gives me 0 over 0.
over
It is
0.
indeterminate form.
Again, yeah.
So that means it could exist. So basically, we will have to figure out what really happens when x is approaching -1. How will you do this question?
Well, sir, you can see that it's sort of a rational function, meaning there's a vertical asymptote and x equals -1, right? So that's how we know that it really won't touch the vertical asymptote, right?
Okay. Now, do you remember absolute function could be defined as a piecewise function?
Yes, sir.
So absolute value x plus 1, how will you define it? It is equal to x plus 1 if x is greater than equal to -1, correct? On the right side, it is positive, right?
Right.
You remember how do you sketch this function? So
Yes, sir.
you remember, right? So x plus 1 means you move left, and then that's your graph, correct? At -1, it is 0, right? This is
Yeah.
absolute value of x plus 1. And this is equal to negative of x plus 1, right? Negative of x plus 1 when x is less than -1, correct?
-1. You're right.
Now, if I have to find the limit at -1, in that case, what will I do? Very important question to understand. You have to find the limit of this function as x approaches -1 from negative side, means left side.
Right.
So if you're approaching from the left side, that means you are on this curve, right? You're on this curve, correct?
Yes, sir.
And therefore, the numerator is equal to minus of x plus 1, correct? So I'll write this function as minus of x plus 1 over x plus 1, correct? And that gives me a value of -1, correct? Because x plus 1 cancel.
Right.
Clear?
Yes, sir.
Since x plus 1 cancel, I get -1. However, if I find the limit of this function from the right-hand side, x approaches -1 from the right-hand side. In that case, I'm actually going on this path. I'm approaching
Okay.
from this side. And
Yeah.
there, the numerator is x plus 1. And if I divide by x plus 1,
X plus
I
1, you
get
get
plus
1.
1. Do you see that?
Yeah.
So the limit from left side is not the same as the limit from the right-hand side.
Yeah.
Since these limits are not same, limit does not
Not
exist.
exist. Yeah.
You have to write all this to answer this particular question. You get the idea.
Yes, sir.
So what we have seen here today is some questions straightforward, just plug it in and get your answer. Those
Yeah.
were the continuous functions.
Right.
For such functions, it was 1 over x kind of a function, like having a vertical asymptote. In those cases, the limit does not exist as the function approaches infinitely large value, which is not a defined real value, correct?
Sir. So for any given rational function, right? If the limit is x approaches the vertical asymptote, then the limit does not exist, right?
Correct.
Right. Okay.
In this case, we have a hole, right? Do you see that?
Yeah.
In this, I mean, it is not equal to -1. So at -1, this is the point which is not really defined. However, when we approach from both the sides, we get two different values, which is
Two different
-1 and
limits.
+1. You get the
Yeah.
idea. And those we are not approaching at the right value,
Right.
correct? And this is also indeterminate form. Indeterminate form is 0 over 0, correct?
Yeah.
And that is why the limit does not exist in this particular case. When we found from both the sides, we clearly came up with values which are not the same, -1 and +1. You get the idea.
Yes, sir. So two different limits.
Two different values. So left side limit exists, and this is -1. Right side limit exists, which is +1. Since both
Right.
left side and right side do not match, the
Yeah.
limit does not exist at x equals to -1. Is that clear to you?
Yes, sir.
So in short, that is where we are going to end our lesson today. So you have many other questions which I'll share with you in the form of my videos. They should
Yeah.
help you to remember what we have talked about and understand the concept. Okay.
Yes,
So
sir.
we can end our class here today. Do you have any questions?
No, sir. I think I really understood the concept of limits, but I definitely have to practice.
Sure.
So yeah.
So that's very good. So you have still to begin with the lessons on calculus. You already know this concept. That's very great. Can you please summarize today's learnings?
Yes, sir. So the entire class was on limits, right? So I really understood how we can approach from the left side and right side, and I really connected it to the unit 2 in advanced functions where we examined the preceding and following interval.
Correct.
But this time we really dealt with more complicated functions by combining, like Euler's number, for example, e equals 1 plus x to the power of 1 over x. We didn't do that in advanced functions, and now I knew how to examine the limit for that function too. So I found that really
Correct.
interesting.
Also, sine functions are defined for radians only. And sine x
Yeah,
over x, the limit x approaches 0 equals to 1, is one of the most important limit which you will come across while doing this lesson on calculus, right?
yeah.
So that's great. You've understood quite a bit, and we'll continue from here in our next class.
Yes, sir, for sure.
Yeah, thank you and all the best.
Thank you so much.